everyone, welcome to Unfog with Dr. Athar Parveen, and today we are going to discuss the chemistry question paper of Hstr examination of year 2015. We will also highlight those chapters from which more number of questions have been asked and those chapters from which the questions may be asked in Hstr exam of 2022. So, let's begin with our class. The substance having the strongest hydrogen bond is HCl, H2O, HI and H2S. Actually, it is water. Water is known for its strongest hydrogen bonding. It has the most strongest hydrogen bonding actually. So, it is actually the water. Then we have the 21st question, which is asking the catalyst. It is asking the catalyst used in the hydrogenation of oils. Okay. So, how is hydrogenation of oils done first of all? So, we'll have an unsaturated compound. Okay. So, unsaturated compound, like there should be a double bond or a triple bond. Then it will be known as unsaturated. So, this is an unsaturated compound, for example. Now, we will add hydrogen to this. It is hydrogenation, right? So, we'll have to add hydrogen. So, after hydrogenation, we get as a saturated compound. So, saturated compounds mean it should have only single bonds. So, this is a saturated bond. But this reaction can only be carried out in the presence of a catalyst, which is nickel. So, nickel is used as the catalyst in the hydrogenation of oils. So, is there nickel? Yes, the fourth option, nickel is the answer. Then we have 22nd question, which is asking the chemical formula of blue vitriol is. So, blue vitriol is a very common compound in the chemistry labs. So, actually it is a blue crystalline solid. So, it is a crystal, right? It should be a hydrated solid because it has a crystal structure. So, its compound formula is CuSO4.5H2O. It is a hydrated crystalline solid. So, is there any option? Yes. Second option, CuSO4.5H2O. This is blue vitriol. It is a blue crystal solid, which is a hydrated crystal solid. Okay. Then next we have this 23rd question. Match the scientists and their discoveries. So, we have the scientists and discoveries column. We have to match. So, Kolbe actually discovered acetic acid. So, let us write down our order here. Kolbe discovered acetic acid, B. Then second question we have is Berthelot. So, Berthelot actually discovered urea. Then third option we have Michael Faraday. Michael Faraday discovered methane, C. Then fourth option will automatically become D. Frederick Wohler. So, do we have any? Frederick Wohler discovered benzene. So, do we have any option which is matching with our series? 1B, okay. All the options are 1B. Then we have 2A, okay. Fourth option is matching. Then we have 3C, okay. Again matching. 4D matching. So, the fourth option is the right answer. Now, the 24th question we have is, one of the following statement is true about calcium hydroxide, CaOH taken twice. First option we have is, it is used in the manufacture of cement. Second we have, it is a light blue solid. Third, it is used in the manufacture of bleaching powder. Fourth, it does not possess disinfectant property. So, actually, the answer is third option. It is used in the manufacture of bleaching powder. See, if you look at it, calcium hydroxide is well known for the production of bleaching powder. So, if you react this calcium hydroxide with chlorine, it will react and give CaOCl2, which is known as calcium oxychloride, CaOCl2. So in other simple words, this calcium oxychloride is nothing but bleaching powder. Okay, so this along with the bleaching powder, it gives us water. So the correct option should be, it is used in the manufacture of bleaching powder, and this is the reaction. It is quite important, so it is better if you remember this reaction. Then the next question we have, 25th question. A solution turns red litmus to blue. Its pH is likely to be. So we have a solution. Okay, it is turning red to blue. Red litmus to blue. So this means it should be alkaline in nature. Now let us take a look at the pH scale. We have pH scale, right? 1 to 7 to 14. Anything that lies between 1 to 7 is acidic in nature. And if it is closer to 1, if the solution is having pH value closer to 1, it is very strongly acidic. If it is closer to 7, it is weakly acidic. This 7 denotes neutral pH, right? Then on this side, if we take a look at it, it is alkaline pH. Okay. So if the pH of the solution is closer to 14, it is very strongly alkaline. And if it is closer to 7, it is weakly alkaline. Okay. But he is saying red litmus to blue. So it should be alkaline. Options are 1, 4, 5 and 10. Right? 1, 4, 5 and 10 में 1, 4 and 5. These lie between 1 to 7. So these are acidic in nature. But we have 10. 10 lies between 7 to 14, somewhere here. So it should be alkaline in nature. So the answer is 10. So a solution which will have a pH of 10 will turn the red litmus to blue. Now next question. Among the following pairs, one will give displacement reactions. So some reaction between these chemical compounds, one will give displacement reaction, it seems. So we have FeSO4 solution with Ag, MgCl2 solution with aluminium, AgNO3 solution with Cu, and NaCl solution and Cu, copper. So in order to find which will give displacement reaction, we need to write down the chemical reactivity series, metal reactivity series it is also known as. So we can write it down as potassium, sodium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, platinum and gold. Now let's make a margin. Oh, we forgot calcium here. Calcium comes below potassium and sodium. So we have potassium, sodium and calcium. So this potassium, sodium and calcium and this. So these metals are highly reactive. These metals are a little less reactive. Okay. And these metals, platinum and gold, these are known as noble metals itself. Noble metals means they have almost nil reactivity. They don't show reactions easily. Okay. So if an element is placed higher in this series, if it will have a higher position, it will be difficult to displace them. Actually, it is not possible to be displaced by the lower element. Okay. So higher position means it is difficult to be displaced by a element placed lower than it. So first let us look at the options. First option we have is FeSO4 solution with Ag. Okay, we have iron here and Ag is placed below it. Silver won't be able to replace iron because it is placed lower in the chemical series, right? So displacement reaction cannot occur in this. The next we have is MgCl2 plus aluminium. We have magnesium here. Aluminium is below magnesium. So aluminium is in lower position. It won't be able to displace magnesium from MgCl2. So no displacement reaction will occur. So again this is the wrong option. Then we have AgNO3 with copper. So we have silver here. Copper is placed above Ag. Okay, so copper has a higher position than silver, right? So it will be able to displace silver from this compound. So displacement reaction can occur. So this is the right option. Now let us verify the last option. Okay, we have NaCl with Cu. In NaCl, the sodium is placed in the most reactive metals. Copper is somewhere below here. So copper won't be able to displace sodium from this compound. So displacement reaction cannot occur. So the correct option is the third option, AgNO3 solution and Cu. Then 27th question we have, while cooking, if the bottom of the vessel is getting blackened on the outside, it means that. So he's saying that we are cooking something in a pot. Okay, and for example, this is some food cooking in the pot and there is this stove. Okay, very ugly stove it is. But anyways, so we have food cooking in the stove. We have the food cooking. So we have the food cooking in this vessel. And he's saying that this vessel is getting blackened on the outside, it seems. So that blackened thing, why is that happening? What does it mean? He's asking the fuel is wet. The fuel cannot be wet. Okay. The fuel is burning. The fuel cannot be wet. So it is the wrong option. The fuel is burning completely. See, so now that we are talking about burning things, now let us take a compound, methane. And we are burning it. Burning, for something to burn, oxygen should be present, right? So this is, we are burning it. So after you burn, you get carbon dioxide and water. Okay. So this carbon dioxide will escape if enough amount of oxygen is present and we are burning it completely. Then there will be the formation of carbon dioxide which will escape into the atmosphere. So no, this black substance formation will not be observed. So it is the wrong option. Next we have the fuel is not burning completely. Now for example, let us take CH4 only. It is a fuel, right? That's why we took CH4 as an example. And we have oxygen again, but it is very less. So if less oxygen is present and you are burning a methane, it will give carbon, only carbon, not carbon dioxide, and water. So this only carbon will show the formation of this black substance on the vessel. So this is the correct option. Option 3 is the right answer. The fuel is not burning completely because less oxygen is present. Not burning completely matlab less oxygen. So carbon will be forming and this black substance will be seen here. Then the food is not cooked completely, it seems. Whether food be cooked or not cooked, nothing will appear on the outside of the vessel. It has no relation to it. So fourth option is the wrong option. Now next question we have is, one of the following metals forms an amphoteric oxide. So amphoteric oxides means they have a powder-like nature. So elements like beryllium, aluminium, zinc, tin, lead, These all form amphoteric oxides. Oxides which have a powder-like look. Okay. So is there any option matching with our elements? We have sodium, calcium, aluminium and copper. So we have aluminium. Third option is the right answer. Now 29th question. An element that is an essential constituent of all organic compounds belongs to. Okay. So we have organic compounds, right? There are so many organic compounds, and the major element we see in organic chemistry is carbon. It is basically the study of carbon in organic chemistry, right? And this carbon belongs to group 14. So the answer is option number 2. The next question we have is a set of alkaline earth metals are. So if we look at the periodic table, the alkaline earth metals are those which come under the group 2. Okay. So what are the elements in group 2? Beryllium, calcium, strontium, barium, radium. So is there any option matching with our series? We have beryllium. Okay, beryllium is here. Magnesium we have. Okay. Calcium we have. Okay. So second option is the right answer. So now let's see the 31st question. He's asking, identify the Dobereiner's triads. So Dobereiner's triads means Dobereiner was actually a scientist. So he gave us a law which says that, let me put it to you in simpler terms. If there are 3 elements, for example, A, B and C in a periodic table, the atomic mass of A, if you add it with atomic mass of C and take its average, take its mean, like atomic mass of A plus atomic mass of C divided by 2, if we do, the number that we will get will actually be the atomic mass of B. Okay, so let me make the statement for you. Atomic mass of the middle element was approximately equal to the arithmetic mean of the atomic masses of the other 2 elements of the triads when they were arranged in increasing order of their mass. Means A has little mass, B has a more mass than A, and C has the most mass. Okay, and he gave us the examples of those triads, like he gave calcium, strontium, barium was one triad he gave. Then other triad he gave was chlorine, bromine, iodine. Then other triad he gave was lithium, sodium, potassium. So here if we add the mass of calcium with barium and take its mean average, then the value that we were getting was the mass of strontium. The same goes for chlorine, bromine, iodine and lithium, sodium, potassium. So is there any option matching with our series? We have lithium. Okay, lithium, sodium, potassium. Okay, the fourth option is the matching option. So it is the right answer. Then we have 32nd question, which is asking, identify the strong electrolyte. So what do we mean by strong electrolyte? So strong electrolyte is the one, if we dissolve it in water, it completely dissociate into its respective ions. So for example, we have some strong electrolyte AB and I'm dissolving it in water. Okay, so it will completely dissociate and give me A plus and B minus ions respectively. Okay, so which of the following in these options is a strong electrolyte? This is actually an organic compound, like, right? This looks like an organic compound, and organic compounds are usually weak electrolytes. So because it is a weak electrolyte, it is not the right option. Then again we have KHCO3. It has hydrogen in it. So again it will have weak electrolyte. Then we have AgNO3. AgNO3 actually dissociates completely to give Ag plus NO minus 3. So when we dissolve AgNO3 in excess water, it will give us Ag plus NO minus 3, its respective ions. So AgNO3 is a strong electrolyte. Then next we have is Na2CO3. This Na2CO3 is again weak electrolyte because it doesn't dissociate completely into water to give its respective ions. So the next 33rd question is asking, nitrogen atom has 3 unpaired electrons and this can be explained by. So we have Pauli's exclusion principle, we have Aufbau's principle, then next we have Hund's rule, and next we have Heisenberg's uncertainty principle. Okay, so he is asking that which one of these will explain why nitrogen atom has 3 unpaired electrons? Okay, actually the answer is Hund's rule, because Hund's rule tells us that every orbital in a subshell is singly occupied with 1 electron before any orbital is doubly occupied, and all electrons in singly occupied orbitals have the same spin. So we are talking about the electrons and how they are placed in their respective orbitals here. So this 3 unpaired electrons, why it has, can only be explained by the Hund's rule. Pauli's exclusion principle states that no one electron of the same atom can have same set of 4 quantum numbers. So that is said by Pauli's exclusion principle. That doesn't give us the reason why nitrogen has the 3 unpaired electrons. Then next we have this Aufbau principle. The Aufbau principle tells us that electrons fill lower energy atomic orbitals before filling the higher energy ones. So again, this does not explain why nitrogen has 3 unpaired electrons. Next we have is Heisenberg's uncertainty principle. So Heisenberg's uncertainty principle tells us that we cannot identify the position and momentum of an electron simultaneously. So this was said by Heisenberg's uncertainty principle. Again, this does not say why nitrogen atom has 3 unpaired electrons. So it is not the right answer. So the correct answer should be Hund's rule. Next we have Rutherford's experiment of scattering of alpha particles showed for the first time that the atom has option 1 electron, option 2 proton, option 3 nucleus, and option 4 neutron. Actually this experiment showed that the atom has a nucleus. Okay, so nucleus is the answer. Then we have an electron with azimuthal quantum number L is equals to -1 cannot be present in S orbital, P orbital, D orbital, or F orbital. This actually azimuthal quantum number L is equals to -1 cannot be present in S orbital. So this is because the L is equals to -1 value is only possible for P, D and F subshells, but it is not possible for S subshells because the value for S subshell is 0. Okay, so L is equals to -1 cannot be present in S orbital. Next 36th question we have, when passing through magnetic field, the greatest deflection is experienced by. So it has a very simple funda here. Okay, what is it? So greatest deflection means it is bending more. When will some ray or any particle have more bending when it is present in that particular magnetic or electric field, when it will have more weight or more mass. So if it is having more mass, it will show more deflection, right? So now we have to find out the ray which has the greatest mass from the rest of the options. First we have the alpha rays. Alpha rays are actually doubly ionized helium atoms. Doubly, matlab it will have more mass than the helium atoms, almost twice. So it will be having very much more mass. So it will show more deflection. So alpha rays are the right answer. But let us look at the rest of the options. But I don't think so the rest of the options can be right, because beta rays are actually made up of electrons. Electrons have negligible mass. So beta rays are the wrong answer. Yes, they will show deflection opposite to that of alpha rays, but they will have lower deflection. Less deflection it will have than alpha rays. Then we have gamma rays. Gamma rays are neutral rays. They won't show deflection only. So again, it is the wrong answer. Then we have neutron. Neutron, from name itself, it has neutral nature, right? So it will again show no deflection. So neutron is a wrong answer. The correct option is alpha rays. Next we have gallium was named by Dmitry Mendeleev as option 1 Eka silicon, option 2 Eka germanium, option 3 Eka aluminium, and option 4 Eka zinc. It is actually option 3 Eka aluminium. Then we have the 38th question. The smallest sized ion among the following is. So option 1 we have N3 minus, option 2 O2 minus, option 3 Mg2 plus, option 4 Al3 plus. And he is asking for the smallest sized ion. So we have N3 minus here, right? So N3 minus means it will be gaining 3 electrons. So if gains 3 electrons, it will have a larger size, right? So N3 minus is the wrong option. Then we have O2 minus. O2 minus will again be gaining 2 electrons, right? So it will also have a large size, but less than compared to N3 minus. Then we have Mg2 plus. Mg2 plus, it is a metals. Metals donate electrons. They lose or give 2 electrons, as in case of magnesium. So it will have a smaller size. Then we have Al3 plus aluminium. Aluminium is again a metal, but here aluminium is giving out 3 electrons. It is donating or giving 3 electrons. So it will be having even smaller size than magnesium. Now he was asking for the smallest sized ion. So here aluminium will have the smallest size ion. The next question we have, the compound which contains both ionic and covalent bond is. So option 1 H2O, option 2 HCl, option 3 KCN, and option 4 KCl. So we have water. Water only has covalent bonds actually. So only covalent bonds means water becomes the wrong option here. Then we have HCl. The HCl, they share an ionic bond here. So HCl becomes the wrong option. There are only ionic bonds, but we want both ionic and covalent bonds. Then next we have potassium cyanide, KCN. So in potassium cyanide, the potassium and the carbon, they share a covalent bond. Sorry, the potassium and the carbon, they share an ionic bond, but this carbon and nitrogen, they share a covalent bond. So there are both the bonds present here, right? So we have option 3 KCN as an answer. But let's look at the fourth option, potassium chloride or KCl. They only share ionic bonding. Between K and Cl, only ionic bonds are present. So KCl cannot be the right answer. So the answer is potassium cyanide, which has both ionic and covalent bonds. Next we have the C2H4. Ethene contains the following bonds. So he is asking us how many sigma and pi bonds are present here. So let us draw the structure of ethene first. Ethene, so C double bond C will be present. Alkenes, no? So it will have 4 hydrogens. H. Now we want to count the number of sigma and pi bonds. So sigma bonds means it is a single bond, and pi bonds means it will have double bond or a triple bond. So multiple bonds are actually pi bonds, right? But how do we count them? These single bonds right off the bat, they are sigma bonds. But here in double bond, this first bond is here, no? This first bond will be taken as sigma bond only because it is a single bond. But this second bond is what makes it as a double bond. So the second bond will take it as a pi bond. Okay. So keep in mind how to count the bonds. In double bond, this first bond will be counted as sigma, second bond will be counted as pi. And in triple bond, the first bond will be counted as sigma, the rest of the 2 bonds will be counted as first pi, then second pi. Okay, that's how you count the sigma and pi bonds. Now that we have counted here, how many sigma bonds are present here? 1, 2, 3, 4, 5. 5 sigma bonds are present here. And pi, only 1 pi bond we have. Okay, so we have 5 sigma and 1 pi bond. Is there any option matching with our answer? We want 5 sigma, 5 sigma, 5 sigma. Yes, the third option, 5 sigma and 1 pi bonds is the right answer. So that was the last question, huh? So now we discussed the whole question paper and we solved the answers. We tried to understand why the answer was the correct option also. So that was the last question. Now that we have solved the question paper, we realized that some chapters were more important than the rest of the chapters. Like first chapter we had basic concepts of chemistry. Remember the mass percentage question we had to solve for urea? Such questions can be asked. Then we had structure of an atom. Thus, structure of an atom, we had to calculate the sigma bonds, the number of pi bonds, the last questions like those. Then we have classification of elements, means periodic table elements. Some questions can be asked. Like we solved the question for Dobereiner's triads, right? Like that questions can be asked. Then we had chemical bonding. That chemical bonding again comes for the sigma and the pi bonds. Such bonding question, ionic bonds and the covalent bonds, crystalline structure or what type of amorphous structure it has. Such questions can be asked. Then we have acids, bases and salts. From acid, bases and salts, we have to solve for that acidic salt. Which one is it? We have to identify. Such questions can be asked. Then we have organic chemistry. Organic chemistry, a little bit of introductory part was only asked, right? Like that preparatory method for ethyne. And such more questions can be asked again. Then we have solutions. Solutions may we had to find out the colligative properties, the colloids. Such questions can be asked. Then we had electrochemistry, the H2O2 fuel cell, the reaction occurring at the cathode. Such questions are actually important. So those are the chapters that you'll have to keep in mind while preparing for the Hstr examinations. So that's it for the today's lesson, everyone. If you liked our video, please like, share and subscribe our channel. It helps us out a lot. And don't forget to comment down in the comment section below. So see you all in the next session, everyone. Till then, bye-bye and all the best for Hstr.